Imagine looking at the universe, right? And seeing this fundamental, just totally unavoidable crack straight down the middle of reality.
Right.
I want you to really picture the sheer scale of this cognitive dissonance. Because on one side of this crack, you have the macro world. You look up at the night sky and you are seeing the smooth, continuous flow of gravity.
Einstein's universe.
Exactly. You are seeing the elegant curvature of space-time mapped out by Einstein, where massive bodies like stars and planets and whatever, they just glide along these invisible, seamless valleys.
It's beautiful.
It is. It is a reality of completely unbroken fields. But then you look on the other side of the crack. You zoom in, you look at the atomic scale, and suddenly, boom, that smooth flowing reality just shatters.
Completely shattered.
You see the jerky, pixelated, fundamentally discrete jumps of quantum mechanics. You see these particles that seem to, pop in and out of existence. Energy that can only be traded in these rigid little packets. Right. And you get these unpredictable leaps from one state to another with absolutely zero smooth transition in between them.
None at all.
So for over a century, the greatest minds in science have basically been staring at this crack, trying to tape it together with increasingly convoluted mathematics. But today, we are exploring a paradigm-shifting framework that suggests something absolutely mind-bending.
Yeah.
It suggests that crack was never actually there.
It is a radical proposition. I mean, we are dealing with a conceptual leap here that attempts to completely upend how we understand the very foundation of physical and mathematical existence.
For sure.
We are looking at a framework that refuses to just build, another theoretical bridge between the discrete and the continuous. Instead, it argues that the very idea of sides, the idea that the discrete and the continuous are fundamentally different categories of nature, is just a profound illusion created by our own limited perspective.
And the source material we are pulling from to unpack this is just phenomenal. We're doing a deep dive into Philip Lilien's groundbreaking 2026 foundational paper. It's titled Generative Closure: The Quantized Continuum as Generative Closure. We also have access to his supplementary briefing documents and some incredibly detailed visual architectural diagrams that attempt to actually map out this new ontology.
The paper itself is programmatic, and by that I mean Lilien is laying down the conceptual bedrock for an entirely new way of doing physics.
Yeah, it's dense.
Very. It is mathematically dense and incredibly rigorous, but its core ambition is almost philosophical, really. He is trying to force us to change the grammar of how we describe the universe before we even start writing the equations.
Okay, let's unpack this. Because to understand why Lilien's solution is so revolutionary, we really have to feel the weight of the problem first. We need to talk about what the paper calls the island view crisis.
The island view, right.
If I'm reading this history correctly, this isn't just a modern physics problem, is it? This crack in reality goes all the way back to antiquity.
It goes back to the very origins of formal human thought. Historically, both mathematics and physics have operated under this unshakable assumption that the discrete, meaning the countable, the separate, the individual unit, and the continuous, meaning the smooth, the unbroken, the flowing, are independent primitive states of being.
Like two different islands.
Exactly. They are treated as separate islands of reality. Think about classical mathematics for a second. You have arithmetic,
which is discrete.
Fundamentally discrete. You count distinct objects. 1, 2, 3. There's a rigid boundary between one integer and the next. Then over on the other island, you have geometry. Geometry deals with continuous magnitudes, smooth lines, perfect circles, unbroken surfaces.
Right, and the ancient Greeks were famously tormented by this.
Oh, they hated it.
They had this beautiful geometric system, but the moment they tried to apply discrete numbers to continuous lines, it completely broke down.
Yeah.
Like they realized that the diagonal of a square couldn't be expressed as a neat, discrete fraction of its sides.
Irrational numbers.
Yeah, the discovery of irrational numbers felt like a glitch in the matrix to them. They couldn't reconcile how a perfectly smooth line could just refuse to be chopped up into perfectly discrete, countable units.
And that profound mathematical discomfort simply carried over century after century, bleeding directly into natural philosophy and eventually modern physics. The source material traces this historical progression beautifully.
So walk us through that.
Well, if we jump forward to Isaac Newtonian dynamics, and the invention of calculus represent the ultimate triumph of the continuous island.
because calculus is smooth.
Calculus is literally the mathematics of smooth change. Newton gave us a universe of smooth, unbroken motion. A ball rolling down a hill, the gravitational pull between the Earth and the Moon. It is all modeled as flowing rivers of force and motion without a single gap or jump.
And it feels intuitive. I mean, when I throw a baseball, it travels through every single point in space between my hand and the catcher's mitt. It doesn't, teleport.
Right.
But then the 20th century arrives, and we zoom in, and suddenly that flowing river looks way more like a hailstorm.
That's a great way to put it. The crisis begins with Max Planck. At the turn of the 20th century, physicists were trying to solve the black body radiation problem. The continuous math of the time predicted that an idealized hot object should emit infinite amounts of ultraviolet light.
Which obviously doesn't happen, or we'd all be fried.
Exactly.
Okay.
To fix the math, Planck had to introduce a desperate hack. He assumed that energy couldn't be emitted in a continuous, smooth flow. It had to be emitted in discrete, countable packets, which he called quanta.
Just chunks of energy.
Right. Suddenly, the continuous river of energy has granular, indivisible chunks in it.
And from there, the discrete island just starts taking over the microscopic world. Niels Bohr takes Planck's quanta and applies it to the structure of the atom itself.
Bohr looks at the atom and says, well, electrons don't just smoothly spiral around the nucleus like planets around the sun. If they did, they would continuously lose energy and crash right into the nucleus.
Because of classical electromagnetism.
Precisely. So he proposes that electrons exist in isolated discrete orbits. And when an electron moves from one orbit to another, it jumps without ever existing in the space between those orbits.
The famous quantum leap.
There it is.
It's a concept that completely defies Newtonian logic. It's like walking up a staircase where you can stand on the first step and you can stand on the second step, but the physical space between the steps is fundamentally forbidden territory. You just cease to exist on step one and materialize on step two.
That visual captures the absurdity of it perfectly, but the history gets even more tangled. Erwin Schrödinger comes along and develops wave mechanics. He tries to bring continuity back into the quantum world by treating particles not as discrete little billiard balls, but as continuous wave functions spreading out through space.
He's trying to save the continuous island.
He really thought he had rescued it. Yet, almost at the exact same time, Werner Heisenberg develops matrix mechanics. Heisenberg describes the exact same physical phenomena using countable, discrete tables of numbers called matrices. Heisenberg's math had absolutely no underlying visual of smooth waves.
So you have two completely different mathematical languages, one speaking in the flowing grammar of the continuous, and the other speaking in the rigid tabular grammar of the discrete.
Right.
And both flawlessly describing the exact same atomic reality.
And ever since that exact moment, theoretical physicists have basically been trapped playing peacemaker. Because they view the discrete and the continuous as fundamentally separate primitive realities, because of this island view, they're forced to build mathematical bridges between them after the fact.
They're constantly translating.
They take a discrete theory and a continuous theory and just try to stitch them together with brute force.
Which brings us to the ultimate failure of the island view. When you assume the discrete and the continuous are primitives, meaning they are the absolute bottom floor of reality and nothing deeper exists below them, you eventually hit a wall you just cannot climb.
The wall is quantum gravity.
Yeah.
When physicists try to bridge the primitive continuous geometry of Einstein's general relativity with the primitive discrete states of quantum mechanics, the equations don't just fail, they explode.
They give you infinity.
Intractable infinities. If you try to calculate the gravitational field of a discrete quantum particle like an electron, the math basically throws up its hands and gives you physical nonsense. The equations suggest infinite energy density, which we know is completely impossible.
Because you are trying to force a translation between two languages that don't just have different alphabets, but completely different fundamental logics. You can't just overlay a rigid grid onto a flowing fluid and expect them to perfectly map onto each other.
This raises an important question, though. Furthermore, the island view creates a massive philosophical blind spot. It makes the deep resonance we actually do see between the two domains seem like a total, inexplicable accident.
What do you mean?
Well, why should discrete mathematical matrices and continuous wave equations yield the exact same physical predictions if they are fundamentally separate realities? The island view forces us into an ontological trap.
Right.
If you start with two isolated islands, you cannot explain the mechanism by which a smooth, continuous space somehow magically yields countable, stable, discrete modes. Nor can you explain how discrete units, like individual particles, manage to exhibit smooth relational coherence, like a wave interfering with itself.
Okay, hold on. I'm losing the thread here a bit. Let me push back. Because while the math might be failing in the extremes of black holes or subatomic particles, my everyday lived experience perfectly validates this island view. Well, a rock is a discrete, localized object. I can count rocks. 1 rock, 2 rocks. It feels entirely different from the water that the rock falls into. The water is a continuous flowing substance. I don't count water, I measure it by volume.
True.
So why shouldn't we trust our fundamental observation that these are just 2 distinctly different physical categories? The math might be struggling to bridge them, but reality tells me a rock is simply not water. Help me bridge that gap.
Your observation is entirely valid, and it is exactly why the island view has survived and dominated for thousands of years. It works spectacularly well at the macroscopic human level of experience.
Right.
But Lilien's argument is that our macroscopic observations are a trap. They are partial, localized views of a much deeper generative process. We are confusing the output of a system with the foundational mechanics of the system itself.
Give me a mechanism then. How can something be both a rock and water at the fundamental level?
Let's use an analogy of self-organizing systems, specifically cymatics. Are you familiar with the Chladni plate experiment?
Oh yeah, that's where you take a flat metal plate, sprinkle loose sand all over it, and then you run a violin bow along the edge of the plate to make it vibrate.
Precisely. Now, before you run the bow, the sand is just a continuous, unstructured field spread across the plate. Now, when you run the bow, you introduce a continuous sound wave, a continuous vibration through the metal. But what happens to the sand? Does it just vibrate in a continuous blur?
No, the sand dances around and suddenly snaps into these incredibly rigid, highly structured, discrete geometric patterns. You get perfect stars, distinct concentric circles, sharp grids.
Exactly. The continuous vibration creates nodes, areas of zero movement, and the sand naturally gathers there. Now imagine you are a tiny observer living on that plate and you have no concept of sound waves.
Okay.
You look at the sharp, discrete lines of sand, and you look at the smooth, bare metal between them. Under the island view, you would classify the sand lines as fundamental discrete objects and the bare metal as the continuous void. You would think they are 2 totally separate realities. But we, looking from the outside, know the truth.
Which is that the discrete lines of sand and the continuous vibration of the plate are not separate realities. The discrete pattern is being internally generated by the continuous wave.
The continuous medium is intrinsically capable of generating discrete stability from within itself without any external discrete ingredient being added. The discrete lines are not alien objects dropped onto the plate. They are the stable, localized manifestations of the continuous vibration's own internal dynamics.
Wow, okay.
Lilien is suggesting that the discrete and the continuous in our universe are just like the sand patterns and the vibrations. They are real, observable regimes, but they are not the bottom layer of reality. They are structural expressions of something deeper.
Which brings us to the absolute core of this deep dive. If the island view is a foundational misframing, if the rock and the water, the discrete and the continuous, are not the bottom layer of reality, what is the bedrock?
Right, what's the plate?
Exactly. What is the actual plate vibrating underneath everything? This leads directly to Lilien's core proposal, which is going to require us to learn an entirely new vocabulary. Let's start with this foundational concept of generative closure.
Yes.
It's represented in the math by the sweeping script letter C. What is it, mechanically?
Generative closure is the beating heart of this entire framework. To understand it, we have to completely unlearn how we normally use the word closure in mathematics.
Okay, how do we normally use it?
Well, in standard set theory, closure is a terminal property. For example, if you take any 2 even integers and add them together, the result is always another even integer. Therefore, the set of even integers is closed under addition. It's a descriptive rule applied at the end of a process to say, yes, this system behaves predictably.
It's just a boundary line drawn around a set of numbers.
Right. But Lilien elevates the concept. He defines generative closure as a productive, active, structural principle. It is the active generator of form.
General?
Yes. It is the internal mechanism by which a continuous, varying regime becomes internally stable, bounded, and reproducible. It is the process that allows a physical or mathematical structure to fold in on itself, to hold itself together, to differentiate itself from its surroundings, and to remain consistent over time. It is not an afterthought or a descriptive label. It is the ontological prerequisite for anything stable existing at all.
So if generative closure is the active mechanism, the engine of stability, essentially, what is the medium it is acting upon? because in the Chladni plate analogy, the vibration is acting on the physical metal plate, what is the cosmic equivalent.
Right.
That brings us to the next term, which is the coherent continuum, denoted by the capital letter K. Now, when I hear continuum or space, I immediately picture an empty void, like a massive, featureless 3D Cartesian grid just waiting for a particle to be dropped into it.
Which is another stubborn legacy of the island view. We treat space as an empty stage and particles as the actors. But Lilien's coherent continuum K is explicitly not a featureless empty background. It is intrinsically structured.
Structured how?
It is a dense topological medium of coherent variation and relational propagation. It's a web of potential relationships. You can think of it as a field of pure relational capacity.
Okay, so we take the active mechanism, generative closure, or C, and we apply it to this relational medium, the coherent continuum, K. What is the output? The paper gives us a beautifully simple equation, Q equals C of K.
Yes.
The quantized continuum, Q, equals generative closure acting on the coherent continuum.
And this Q, the quantized continuum, is the primary ontological regime. This is the bedrock of reality. This is the level where continuity is intrinsically capable of generating discrete stability from within itself.
Because it closes in on itself.
Exactly. And what is so revolutionary here is that Lilien is completely redefining the word quantization. In traditional physics, quantization is treated as a verb that an outside force does to a system. We artificially impose a rigid mathematical grid over a smooth wave to force it to yield discrete numbers.
We force the continuous to behave discretely because our math demands it.
But in this framework, quantization is not a mathematical trick imposed from the outside. Quantization is a structural event. It is what happens naturally when generative closure stabilizes a mode within the coherent continuum. Think back to the Chladni plate.
The discrete lines of sand, the quanta, are the structural events caused by the closure dynamics of the vibrating plate.
You've got it.
Okay, I want to make sure I'm fully visualizing how this localized pinching actually works mechanically.
Yeah.
Because if the continuum is everywhere, how does it suddenly become discrete in one specific spot?
Think about a whirlpool in a flowing river. The river itself is a continuous flowing medium. But when the flow of the water encounters certain internal relational dynamics, maybe opposing currents or a shift in the riverbed, the water folds in on itself. It begins to spiral.
Okay.
It achieves a localized, stable, reproducible geometry. That whirlpool is a discrete entity. You can point to it, you can track its movement, it has a boundary, but what is it made of?
It's made of the exact same continuous water as the rest of the river.
Precisely. The whirlpool isn't an object dropped into the river. It is a closure-stabilized region of the river. The internal relational dynamics of the water achieved a state of generative closure, localizing the flow into a stable, discrete form. The continuous river generated the discrete whirlpool from within itself.
So that's Q equals C of K.
This is what Lilien means by Q equals C of K. The quantized continuum differentiates into either discrete or continuous regimes depending entirely on the localized intensity of the closure dynamics.
That is a brilliant mechanism.
Yeah.
We aren't looking at two different fundamental substances. We are looking at one continuous relational field, and particles or discrete states are just topological whirlpools where the field has stabilized itself. It's a total perspective shift.
It changes everything.
And having established this new ontological bedrock, we now have to test it. We have to apply this lens to the two great towers of human thought, mathematics, and physics to see how it actually unifies these separated disciplines.
Let's do it.
Let's start with mathematics. How does a generative closure fix the ancient split between arithmetic and geometry that tormented the Greeks?
This is where Lilien introduces the concept of closure mathematics. Now, it is important to clarify that Lilien is not arguing that arithmetic and geometry are literally the exact same thing. You obviously cannot use the exact same mathematical tools to count discrete integers as you use to measure the curvature of a continuous sphere.
Right, that would be chaotic.
But closure mathematics treats these apparently distinct mathematical domains not as isolated primitives, but as differentiated regimes of a shared underlying closure architecture.
So how do we redefine the discrete under this framework? If a number isn't just a fundamental, irreducible concept, if it's not a brute given, as the paper calls it, what actually is a number?
In classical math, the number one just exists. It is an a priori concept. But in closure mathematics, a discrete number or a combinatorial system is the result of closure localizing a relational distinction until it becomes stable enough to support a reproducible pattern.
Okay, walk me through that.
If you imagine the mathematical continuum as a vast field of pure potential relation, Generative closure can operate with incredibly high intensity. It pinches that field, folding it in on itself so tightly that it localizes a distinction. That highly localized, stabilized pinch in the mathematical field is what we perceive and utilize as a discrete number.
Okay, so numbers are intense, highly localized whirlpools of mathematical closure. They are tightly bound relational structures. What about the continuous? How does this framework redefine geometry and topological analysis?
Well, if the discrete represents highly localized, intense closure, the continuous represents broadly distributed, sustained closure. Geometry and analysis describe the sustained relational coherence of a mathematical field where variation can happen smoothly without the structure fracturing.
So it doesn't pinch as hard.
Exactly. It's closure operating at a lower, broader intensity, allowing for smooth extension and relational propagation over a wide topological area.
This introduces a concept the paper calls graded closure, which seems like the master key to this entire mathematical section. The idea is that closure isn't just a binary on-off switch. It operates on a sliding scale, a spectrum of intensities and scopes. High intensity, highly localized closure yields the discrete math of arithmetic and algebra. Broad, distributed, sustained closure yields the continuous math of geometry and topology.
And if you apply that lens, it brilliantly demystifies why certain highly advanced mathematical fields exist at all. Think about the massive successes of fields like algebraic geometry or spectral theory or harmonic analysis.
Right.
These are fields that sit directly on the boundary between the discrete and the continuous. They use the rigid, discrete tools of algebra to flawlessly describe smooth, continuous geometric spaces. Under the old island view, this is a profound, almost mystical mystery. Why should the discrete equations of an algebraic ring map perfectly onto the continuous curves of a geometric manifold? They are supposedly speaking completely different languages.
Right. It always felt like physicists just got incredibly lucky that the math somehow translated across the void.
But under closure mathematics, it's not a lucky translation. The correspondence is inevitable. Algebra and geometry resonate perfectly because they are just different stabilizations of the exact same shared generative field. The deep correspondences we see in advanced mathematics, where a theorem proven in algebra solves a problem in geometry, are exactly what you would expect to see if all of mathematics is just a layered, graded articulation of a single underlying closure dynamic.
Here's where it gets really interesting, though. The paper makes a philosophical leap here regarding the concept of mathematical proof that really caught me off guard. Usually we think of a mathematical proof purely as a human logical construct. Step A logically leads to step B, therefore step C must be true. The synthetic game of logic we play in our heads.
Yes.
But Lilien argues that a mathematical proof is actually the revelation of internal necessity. What does that mean in the context of closure?
It means we have fundamentally misunderstood what we are doing when we solve an equation. A proof is not just a human being applying a set of arbitrary logical rules. A proof is the act of demonstrating that once a mathematical structure is stabilized by specific closure conditions, certain relations must unavoidably follow from within that coherence.
Give me an example to really ground that.
Think about a triangle. The internal angles of a flat triangle always add up to 180 degrees. Under the old view, we say this is true because of the logical axioms of Euclidean geometry. We proved it with logic.
Right.
But under Lilien's view, the triangle is a specific closure regime. Once closure stabilizes three intersecting lines in a continuous flat plane, the 180-degree internal relation is an unavoidable structural necessity of that stabilization. The proof is simply us tracing the inevitable architectural consequences of how closure organized that specific shape. We aren't inventing the logic, we are just mapping the architecture of the stability.
That makes mathematics feel so much more organic, almost biological. It's not a dry set of arbitrary rules handed down from on high. It's the empirical study of how pure relational reality stabilizes itself.
Exactly.
And because mathematics is the formal, abstract articulation of closure, and physics is the literal, physical instantiation of it, we can now map this exact same graded architecture directly onto the physical universe. We can use it to solve the particle-field duality that has haunted quantum mechanics. Let's look at closure physics.
This is where the philosophical groundwork yields massive physical dividends. In standard physics, even today, reality is largely imagined as being built from elementary objects, particles, moving through an empty extension space. It is the ultimate manifestation of the island view.
Yeah.
But in closure physics, the physical universe is not built from isolated objects sitting in a void.
So if a particle isn't a tiny solid billiard ball bouncing around in empty space, What actually is a physical particle in Lilien's framework?
A particle is redefined as a field closure. Remember our discussion of discrete numbers as localized whirlpools of mathematical closure.
Yeah.
A physical particle is the exact physical equivalent. It is a closure-stabilized localization of the field-like continuum. The particle is not an alien object interrupting the continuous field. It is a localized knot in the field. It is a region where the physical continuum has achieved a highly localized, remarkably stable internal configuration.
It's the whirlpool in the river.
Yes, and the physical field itself, like the electromagnetic field or the gravitational field, is redefined not as an empty space containing forces, but as a broadly distributed continuous closure regime.
Okay, I see.
Therefore, the field and the particle are not two ontologically different things. They are the exact same underlying quantized continuum, just experiencing different grades of generative closure.
Okay, if particles are just localized whirlpools in the continuum, how does this explain quantum spectra? In quantum mechanics, a spectrum like the specific discrete wavelengths of light that a hydrogen atom can emit has always been bizarre.
Extremely bizarre.
Why does the atom only emit very specific discrete colors of light and not a smooth, continuous rainbow? Why does the energy only come in rigid steps? Lilien calls a spectrum a closure signature, denoted by the mathematical symbol M star. Walk me through what an M star signature is.
The term closure signature is vital here. A discrete spectrum is not just an arbitrary list of allowed energy levels dictated by some unknown cosmic law. An M-star signature indicates exactly which structural modes of the continuum are mathematically and physically allowed to stabilize and persist under a specific set of local constraints.
Explain the mechanics of that constraint, though. How does that happen?
Let's use an acoustic analogy. Think of the vibrating string of a guitar. When you pluck that string, it doesn't just vibrate chaotically at every possible frequency. It vibrates only at specific, discrete harmonic frequencies.
It's tuned.
Because the string had clamped down at both ends. Those physical boundaries, the length and tension of the string act as physical constraints. The continuous vibration of the string is forced to fold back on itself, wave interfering with wave, until only the stable resonant frequencies survive.
The boundaries of the string dictate its stable modes.
Exactly. The physical constraints of the string act as a form of generative closure. The discrete harmonic frequencies that emerge are the closure signatures of that specific string. Lilien is applying this acoustic logic universally to the quantum realm. The discrete observables we measure in the lab, the specific energy levels of an electron, its spin, its momentum, are not arbitrary rules.
They're resonances.
They are the stable resonant closure modes of the quantized continuum under the specific local conditions of that atom. The atom acts like the clamped ends of the guitar string, forcing the continuum to stabilize only at specific M-star signatures.
And this right here, this physical mechanism, seems to provide a silver bullet for the most notorious headache in modern physics: the measurement problem. Let's take a minute to really unpack the measurement problem, because it is the ugliest legacy of the island view.
It really is.
The standard Copenhagen interpretation of quantum mechanics basically says that before you look at a particle, it doesn't exist as a discrete object. It exists as a continuous smear of probabilities, a wave function strutting out through space. But the exact instant you measure it, the instant a conscious observer or a macroscopic machine interacts with it, that flowing wave function violently collapses into a single discrete particle point.
It is a deeply troubling concept. It places an immense, almost magical ontological weight on the act of measurement. It implies that human observation fundamentally alters the nature of the universe, that the act of looking forces a continuous reality to instantaneously transform into a discrete reality.
Yeah, Einstein famously hated this.
He did. He asked if the moon only existed when we looked at it. Physicists have spent a century trying to explain away this wave function collapse because it feels like bad philosophy masquerading as physics.
But Lilien's framework seems to dismantle the need for a collapse entirely. How does closure physics solve the measurement problem?
By removing the magic from the observer entirely. Under closure physics, those discrete observables, the specific energy levels or positions, are already closure-stabilized modes. The quantized state, that Mun-star closure signature, isn't mysteriously created by the act of measurement. It is already a stable feature of the continuum's internal architecture, generated by the local constraints of the system.
So the continuous wave doesn't magically turn into a discrete particle just because I looked at it?
No, not at all.
Yeah.
Measurement doesn't force the continuum to collapse into a discrete state. Measurement is simply a physical interaction where a macroscopic apparatus apparatus encounters, couples to, or structurally selects a discrete mode that was already closure stabilized by the system itself.
So going back to the Chladni plate with the sand, the discrete geometric patterns of sand are already forming due to the continuous vibration. When I take a photograph of the plate, when I measure it, the flash of my camera doesn't cause the sand to suddenly snap into a star shape. The structural event was already happening, driven by internal closure. My measurement just recorded a stable mode that was already there.
Exactly. Closure precedes the act of measurement. The measurement apparatus is just another physical system made of closure regimes, and when it interacts with the quantum system, they couple together according to the internal relational rules of closure. It entirely removes the mysticism from quantum mechanics and returns it to structural relational physics.
Okay, I have a big theoretical question then. What does this regrounding mean for the concept of physical loss? We talk about the law of conservation of energy or the law of conservation of momentum as if they are these unbreakable cosmic speed limits. If everything, particles, fields, math, is just different localized intensities of closure dynamics, what is a physical law?
It forces us to ask why the universe has habits at all. Typically, we think of a physical law as either an arbitrary mathematical rule imposed on the universe from the outside by a creator, or just a human observation of a habit the universe seems to inexplicably have. But in closure physics, a physical law is defined as the patterned regularity of closure action.
Meaning what exactly?
Well, take the conservation of total energy. In this framework, a conservation law is essentially a closure success. Things persist over time, like the total energy of a closed system, because generative closure has structurally made their persistence possible. A physical law is just our mathematical articulation of how closure maintains stability within a specific physical regime.
Okay, that's fascinating.
The universe follows laws not because it is reading a cosmic rulebook, but because the universe is fundamentally an engine of generative closure, and the laws are simply the descriptive geometry of how that engine prevents its own structures from dissolving into chaos.
That is breathtakingly elegant. It takes all these totally disparate, confusing pieces of the universe, discrete particles, continuous fields, quantum leaps, the measurement problem, the laws, thermodynamics, and threads, a single, unbroken conceptual string through all of them.
It unifies them.
And this radical redefinition of what reality actually is sets the ultimate stage. Because now we have the exact conceptual tools needed to tackle the Holy Grail, the most stubborn, career-ending problem in all of theoretical physics: quantum gravity.
Quantum gravity is the crucible. It is the ultimate test for any foundational framework. For nearly a century, from Einstein to Hawking, the greatest minds in physics have battered themselves against this wall and failed. The standard problem, as we established earlier, is that general relativity is a theory of primitive, smooth, continuous geometry. Space-time is a fabric that bends. Quantum theory is a theory of primitive, discrete states, probabilities, and jumps.
So under the island view, physicists basically had two choices. Option A: how do you quantize geometry? How do you take the smooth fabric of space-time and forcefully chop it up into little, discrete, pixelated chunks of space? Or option B: how do you geometrize a quantized world? How do you take a jittery, jumping quantum particle and smear it out so it behaves like a smooth gravitational curve?
And every single mathematical attempt to do either of those things, whether through string theory or loop quantum gravity or perturbative methods, runs into massive foundational friction. The infinities pile up. The math suggests that at the center of a black hole or at the moment of the Big Bang, physics simply stops working. It is the ultimate proof that the island view is a dead end.
But Lilien's reframing sidesteps the wall completely. He relocates the problem. He says we have been asking the wrong question for 100 years. We have to stop trying to force alien ontologies together.
Lilien posits that both the continuous geometry of gravity and the discrete states of quantum mechanics are just coupled regime expressions of the single quantized continuum, Q. We aren't supposed to figure out how to mathematically combine them because they were never separate to begin with. We are supposed to recognize the deeper generative root from which they both grow.
Let's use the visual diagrams provided in the source material to map this out for the listener, because the geometry of this idea is stunning. Imagine a massive 3D architectural rendering of reality. On the left side of this landscape, you have the geometric sector, denoted by G.
Right.
Picture smooth, sweeping valleys, deep, sloping gravity wells where planets rest, rolling, continuous topological hills. This represents large-scale relational order. This is the domain of general relativity, where closure operates broadly to maintain smooth, continuous extension.
And then, as your eyes pan over to the right side of this landscape diagram, the terrain changes violently. This is the spectral sector, denoted by S. Here, you don't have smooth valleys. You have incredibly sharp, glowing peaks, highly localized wave spikes, rigid stair-step plateaus that represent discrete quantum energy levels.
Like quanta.
This is the domain of quantum mechanics, where closure operates with high intensity to create localized, stable, discrete modes.
Under the old island view, these two landscapes were literally on different planets. You couldn't even see one from the other. But in Lilien's diagram, if you look beneath the sweeping valleys of the geometric sector, and beneath the sharp peaks of the spectral sector, you see they are resting on the exact same subterranean foundation. Beneath both of them is the unified bedrock of the quantized continuum, Q. They are just different surface features pushed up by the exact same tectonic plate.
And this visual metaphor is captured rigorously in Lilien's minimal mathematical schema, which he calls the quantum gravity functional. It is an equation that looks deceptively compact, but it carries immense ontological and mathematical weight. It is essentially the blueprint for rewriting physics.
Okay, let's walk through this functional piece by piece, because this is where the theory actually has to prove itself mathematically. The equation is, and bear with me, math functional f of q equals f sub g of g plus f sub s of s plus f sub int of g and s.
Let's break down exactly what that means mechanically. The script f represents a mathematical tool that maps a whole space of functions to a single value. Here, f of q represents the total closure dynamics of the quantized continuum. It is the total mathematical description of how reality stabilizes itself. And the equation states that this total reality is made up of three interacting components.
Let's take the first term then, f sub g of g.
That is the geometric closure contribution. Operationally, this term mathematically describes how closure acts across large scales to create continuous relational order. It is the math of the smooth valleys. In the limit where this term dominates the equation, you recover the mathematics of Einstein's general relativity.
Okay, so the first term gives us gravity. The second term is f sub s of s.
That is the spectral closure contribution. This term calculates how closure acts locally with high intensity to create bounded, stable, discrete quantum modes. It is the math of the sharp peaks. When this term dominates, you recover the standard models of quantum mechanics.
Now, under the old view, physicists basically just tried to add those two terms together and cross their fingers. But Lilien introduces the third term, which is the entire crux of the paper, f sub int of g and s, the interaction term. How does this term physically couple the smooth valleys and the sharp peaks? What is the mechanism?
The interaction term mathematically formalizes the idea that geometry and quantization are mutually constraining. They are locked in a feedback loop. Think of it as a boundary condition. The local spectral intensities, the sharp quantum peaks, dictate and constrain the global geometric curvature of the space around them. Simultaneously, the large-scale global curvature, the smooth gravitational valleys, constrains which specific quantum modes are allowed to stabilize locally.
So they are constantly negotiating with each other.
Exactly. This internal coupling term proves that geometry and quantization do not exist in isolation. They arise in structured, mutual interaction from the very start. The presence of a sharp quantum peak physically alters the shape of the smooth valley, and the slope of the smooth valley determines how tall the quantum peak can grow.
So quantum gravity is no longer the study of how to quantize a classical geometry.
Right.
We weren't trying to chop up space. And it's not the study of how to smooth out a quantum substrate. Quantum gravity is explicitly the study of this coupled closure dynamics. It is the study of that interaction term, understanding exactly how the quantized continuum simultaneously generates both the smooth valleys and the sharp peaks, and how they mutually balance one another at the bedrock level.
And that reframing completely bypasses the intractable infinities of the past century. Because you are no longer forcing a discrete math to behave like a continuous math, you are simply calculating the internal relational dynamics of a single unified continuum that is expressing itself in two coupled ways.
It is brilliant. But let's take a step back from the heavy math, because if we accept this physical reframing, it doesn't just change the equations on a chalkboard in a university physics department. It fundamentally changes our philosophy of what reality is and how we can even know anything about it. This brings us to the final section of the paper, ontological and epistemological consequences. Let's start with the shift to a relational ontology.
This is perhaps the most difficult conceptual hurdle for the human mind to clear. In traditional classical physics, we intuitively think of entities as the primary reality. We think the universe is made of stuff. Particles, atoms, physical objects. These entities exist first as primitive building blocks, and then they interact with each other, creating relations. The things precede the relationships.
Right, like I have to exist and you have to exist before we can have a conversation.
But under generative closure, that logic is perfectly inverted. Relation is structurally and ontologically primary to the entity.
I'm going to need you to unpack that.
Yeah.
How can a relationship exist before the physical things that are relating?
Because the things, the entities, the electrons, the localized numbers only exist in the precise locations where closure has stabilized a pre-existing field of pure relations into a reproducible form. The coherent continuum K is a vast, unformed web of potential relation. It is pure relational capacity.
Okay.
Generative closure operates on that web, pinching it, folding it, stabilizing a specific, highly localized knot of relations. That stable knot is what our macroscopic senses perceive as an entity.
So the relational web exists first as the foundational medium, and the particle is just a localized byproduct of that web being tied into a stable knot.
Right.
We are not made of microscopic stuff. We are made of stabilized mathematical relationships.
Exactly. And if we connect this to the bigger picture, it leads directly to the next major consequence, which is the concept of a stratified reality. If you connect this relational ontology to the macro level, it elegantly demystifies one of the greatest mysteries in science: emergence.
Emergence is essentially how we get complex behaviors from simple building blocks. How do you get complex chemistry to emerge from basic quantum physics? How do you get living biology to emerge from dead chemistry?
Under the old island view, emergence is incredibly frustrating. It almost feels like magic. How do you stack enough dead carbon atoms together to suddenly get a living, breathing, dividing cell? The gap seems unbridgeable, but in Lilien's framework, the universe has a fundamentally layered, stratified ontology. Plurality, the existence of the microscopic quantum world and the macroscopic classical world, is just the differentiated unfolding of graded closure over time.
Explain how closure drives that unfolding.
The engine of generative closure never stops. Once it stabilizes a regime at the quantum level, creating stable particles, those particles become a new baseline. Closure then operates on the relations between those particles, stabilizing them into atoms. Then it operates on the relations between atoms, stabilizing them into molecules.
Scales up.
Higher order structures like a protein, a living cell, or an entire complex ecosystem aren't magical new substances added to the universe. They are simply new, stable, relational regimes appearing as graded closure manages to stabilize vast networks of relations at larger and larger macroscopic scales.
The engine of closure just keeps churning, constantly finding new, highly complex ways to fold the continuum into stability. It's an architecture of infinite nesting dolls. But the wood making up every doll is the exact same generative closure.
Precisely. And if reality is structured this way, it radically changes our epistemology, our theory of knowledge. What does it actually mean to know a fact in physics or biology? It's no longer just recording isolated data points or observing disconnected phenomena. Lilien redefines the acquisition of knowledge as closure tracing.
Closure tracing. What does that look like operationally for a scientist?
When a scientist studies a physical system, whether it's the orbit of a planet or the folding of a protein, they are essentially reverse engineering the stability of reality. They are tracing the specific paths of how closure managed to stabilize that exact structure, and they are mapping how that structure's boundary conditions relate to its neighboring regimes. Science is no longer the cataloging of stuff. It becomes the rigorous study of how the universe successfully holds itself together against chaos.
Okay, I am entirely captivated by the elegance of this framework, but I have to push back hard here at the end, because we need to be very clear about what this paper actually achieves and what its limits are. The briefing documents are incredibly specific about what Lilien does not claim. He is not claiming he just solved physics and everyone can go home.
No, absolutely not. It is vital to emphasize that this is a foundational programmatic proposal. It is a philosophy of physics, backed by rigorous mathematics, but it is not a fully axiomatized, testable final theory. It does not hand us the final, completed mathematical machinery to instantly replace all existing physics. It does not throw out Einstein's field equations of general relativity, and it does not throw out Schrödinger's wave equations.
Because those equations are incredibly successful. They predict reality flawlessly within their own domains.
Exactly. What Lilien is doing is regrounding them. He's showing that general relativity and quantum mechanics are limit regimes. They are partial, specialized views of a deeper, unified architecture. General relativity works perfectly, without error, in the limit where the geometric closure term dominates the system. Quantum mechanics works perfectly in the limit where the spectral closure term dominates the system. Lilien isn't destroying the old physics. He is building the basement that supports both of their towers.
So if this is just the blueprint, what is the next step? How does this philosophical conceptual reframing become a workable, testable theory for experimental physicists in a lab? How do we prove that closure tracing is actually describing physical reality and not just a neat mathematical trick?
That is the multi-million-dollar question that will define the next 50 years of theoretical physics. The outlook requires immense mathematical heavy lifting from the global physics community. Physicists and mathematicians need to collaborate to develop the explicit, detailed, formal language of these closure regimes. They need to see if this conceptual redescription can yield novel, testable predictions that standard physics cannot.
They need to find the math for the interaction term.
Exactly. The ultimate goal is to find the explicit, solvable equations for the coupling term. If physicists can mathematically describe exactly, dynamically, how geometric space-time closure and spectral quantum closure constrain and couple to each other at the Planck scale, they will have essentially written the first true working equation of quantum gravity. Lilien has provided the architectural blueprint. Now the physics community has to actually build the machine.
And what an unbelievable blueprint it is. We've covered an immense, paradigm-shifting amount of ground today. Let's try to synthesize exactly what we've discovered. We started with the island view crisis, the ancient, stubborn, and ultimately mathematically doomed idea that the discrete and the continuous are separate, rival realities.
We examined how that island view forced physics into intractable infinities, creating a universe that felt mathematically fractured. And then we saw how Philip Lilien's framework of generative closure completely dismantles that fractured view. The discrete and the continuous are not ontological rivals. They are not isolated islands. They are dual, coupled expressions of a single underlying relational engine.
The island view is dead. The quantized continuum is the new ground of reality. It's a unified, relational medium capable of internally generating its own stable, discrete modes. It seamlessly unifies arithmetic and geometry under the umbrella of closure mathematics, and it unifies particles, continuous fields, and the laws of thermodynamics under closure physics.
Most importantly, it completely relocates the hardest problem in science. Quantum gravity is no longer viewed as an impossible battle between a smooth macroscopic geometry and a jittery microscopic discrete state. It is now fundamentally understood as the study of how both of those physical regimes emerge, intimately coupled and mutually interacting from the exact same foundational bedrock.
It is a stunning, elegant, and deeply unifying reframing of reality. But before we sign off, I want to leave you with one final, slightly provocative thought to mull over on your own. We've spent this entire deep dive talking about objective physics and abstract math. We've established that physical particles, flowing gravitational fields, and even abstract mathematical numbers are all just closure signatures. They are stable, localized relational patterns emerging from a much deeper, continuous, unified generative field.
Yes. The universe is a single, continuous web of relations stabilizing itself.
So what does that imply about human consciousness? We experience our own minds as highly discrete, localized entities. I feel like a completely separate, bounded consciousness from you. But if the physical and mathematical universe works through generative closure, our individual discrete thoughts, our memories, our very identities, just highly localized closure signatures, stabilizing temporarily within a broader, continuous field of universal cognition. If the universe is fundamentally a single, continuous relational web that folds itself into discrete structural illusions, are we just the universe folding itself into the temporary illusion of an individual mind? Now that is a profound deep dive for another day. Something to really think about the next time you look out at that crack down the middle of reality and realize that the crack, and maybe even you observing it, was never really separate from the whole to begin with. Thank you for joining us as we unpack the architecture of reality itself. We'll see you next time.